sensible cooling, humidification and dehumidification, cooling and dehumidification, cooling and adiabatic humidification, cooling and humidification by water injection means evaporating cooling, heating and humidification by steam injection, heating and dehumidification means adiabatic chemical dehumidification, and last one is adiabatic mixing of two air streams. Then this session is start with the sensible heat. The heat is nothing but energy transfer without changing mass. That heat is mainly divided into two categories, sensible heat and latent heat. In this slide, the sensible heat is equals to mass of air into humid specific heat CPM into delta T. Means mass of air is equals to volume into density. Means V into density into specific humid heat into difference in dry bulb temperature. This equation in the terms of kilojoule per minute, where V is the rate of dry air flowing in the unit of m cube per minute, then density of moist air at 20 degrees Celsius and with 50% relative humidity. It is taken as 1.2 kg per m cube of dry air. Then CPM is nothing but humid specific heat. The constant value for humid specific heat is 1.022 kilojoule per kg Kelvin, and delta T is the difference between dry bulb temperature means TD1 minus TD2 between the entering and leaving conditions of air in degrees Celsius. Then in next step, the substitute the value of density and humid specific heat in above equation, then we get sensible heat is equals to rate of dry air into 1.2 means density into 1.022 means humid specific heat, and delta T means difference in dry bulb temperature. Then we will get 1.2264 into V into delta T. Means final equation for the sensible heat is 0.02044 into V into delta T in kilojoule per second means in kilowatt. Means sensible heat, it is related with the rate of dry air and difference of dry bulb temperature between entering and leaving the condition. The next important point is latent heat. The latent heat is equal to mass of air into delta H means mass of air into HFG into delta W. Means mass of air is equals to volume into density, then latent heat is equals to volume into density into HFG into delta W, where V rate of dry air flowing in the terms of m cube per minute, then density of moist air, it is taken as 1.2 kg per m cube of dry air, then HFG latent heat of vaporization is nothing but 2500 kilojoule per kg, and delta W is nothing but difference of specific humidities between entering and leaving the conditions of air. Means for humidification it is W2 minus W1, and for dehumidification it is taken as W1 minus W2. The substituting these values in the above equation, then we will get latent heat is equals to V into 1.2 into 2500 into delta W. Means latent heat is equals to 3000 V into delta W in the terms of kilojoule per minute. In terms of kilojoule per second means in kilowatt, the latent heat is equals to psychrometric process of sensible heating, and right hand figure shows the sensible heating process in psychrometric chart. The heating of air without any change in its specific humidity is known as sensibility. The air at temperature TD1 means diapole temperature at point number 1 passes over the heating coil of temperature TD3 as shown in figure. It may be noted that the temperature of air leaving the heating coil TD2 will be less than TD3. The process of sensible heating on psychrometric chart is shown by the horizontal line 1 to 2 and extending from left to right as shown in figure. The point 3 represents the surface temperature of heating coil. The heat absorbed by the air during the sensible heating may be obtained from the psychrometric chart by the enthalpy difference of S2 minus H1. It may be noted that the specific humidity during the sensible heating remains constant, means W1 is equals to W2. The dry bulb temperature increases from TD1 to TD2 and relative humidity reduces from phi1 to phi2 as shown in figure. The amount of heat added during sensible heating may be calculated by using this relation. Heat added Q is equals to H2 minus H1 means CPA into bracket TD2 minus TD1 plus W into CPS into TD2 minus TD1, where CPA means specific heat for air, CPS means specific heat for steam, TD2 means dry bulb temperature at point number 2 and TD1 means dry bulb temperature at point number 1. Then Q is equals to, in first bracket, CPA plus W into CPS into second bracket TD2 minus TD1 means CPM into bracket TD2 minus TD1. The term CPA plus W CPS is called humid specific heat. It is denoted by CPM and its constant value is 1.022 kilojoule per kg Kelvin. Then final equation for sensible heating, Q is equals to 1.022 into bracket TD2 minus TD1. This relation in the terms of kilojoule per kg. The next important psychrometric process, sensible cooling. The left hand figure shows psychrometric process for sensible cooling and right hand figure shows the sensible cooling representation in psychrometric chart. The cooling of air without any change in its specific humidity is known as sensible cooling. Suppose the air at the temperature of TD1 passes over the cooling coil of temperature TD3 as shown in figure. The temperature of air leaving the cooling coil TD2 will be more than TD3. The process of sensible cooling on psychrometric chart is showing the horizontal line from 1 to 2 and extended from right to left. The point 3 represents the surface temperature of cooling coil. The heat rejected by air during specific heat and it is represented by CPM. Its constant value is stream of dry air as shown in figure. The final condition of air depends upon is equals to mw1 divided by ma into bracket hf The mass balance W2 is equals to W1 plus Ms upon Ma, means for heat balance H2 is equals to H1 plus Ms divided by Ma into Hs, means H2 is equals to H1 plus W2 minus W1 into Hs, where the Ma is nothing but mass of air, Ms is nothing but mass of steam supplied, W1 specific humidity of air entering, W2 specific humidity of air leaving, H1 enthalpy of air entering, H2 enthalpy of air leaving, Hs the enthalpy of steam injected into the air. Is adiabatic chemical dehumidification. This process is mainly used in industrial air conditioning. It is normally used for some comfort air conditioning installation where the low relative humidity and low dew point temperature is required. In this process, the air is passed over the chemicals which having the affinity for the moisture. The figure shows the fog region. When the warm and high humidity air is mixed with cold air, the resulting mixture will be formed fog. Also result when the steam or very fine water spray is injected into air in a greater quantity than the required saturated air. References. For more details, you can refer textbook of refrigeration and air conditioning by R.S. Gupta. This video is prepared for the academic use only, for the understanding of basic concepts of students related with the psychrometric process, sensible heat and latent heat. Thank you very much.